Okay, so as he said, I'm Mariano Palomo. I work as a malware analyst at Entelgy Tech Security. As part of my work there in the company, one of them is like try to search for new or trendy threats that are active in the moment. And suddenly one day in the beginning of the year, I was checking my Twitter timeline and I found a malware analyst that I follow posted something talking about something called Balder Stealer, and he shared an hybrid analysis link that is a sandbox, public sandbox, and also he shared the C2 panel URL. So as I checked the hash file in the sandbox, I was able to download the sample. And this is the sample that he shared. And always there I found a new binary to analyze, and I don't know any previous info about it. I tried to gather some previous info. So I loaded in a tool called Detector-Easy, which give me some compiler detections based on some signs it has. I was able to check that this binary was compiled with C++. So once I know that, I also load the binary in another tool called pbeer from a malware analyst called Hasherosaid. And I quickly discovered that the data section that is colored in green there is way, way bigger than the others. So maybe this binary is hiding something in that section. So as it was compiled with C++, I only can check the assembly code. So I need a proper disassembler to check that code. And I use IDA Pro for that. And I quickly discovered that he was using, if you don't see, I will zoom in. It was using a load library, so it loads some APIs dynamically, and I checked one called CLR create instance that is used to load reflective binaries, .NET binaries. And then I also checked there was some memory movings here in that part, and then there was an XOR algorithm apply with that keys and another buffer that were stored in that data section. So yeah, looks like something is hiding inside. And I ran the sample in a debugger, and I checked that I checked the same in here, and I saw the memory allocated that was moving these values here. And then there was a loop that was doing an XOR over a buffer, and this is the buffer. And then I check that letting the whole loop running, putting a breakpoint in the end, I checked that there was a p header decryption there. So I dump it from the memory, and then as I have another new binary, I did the same, and I checked this one was a .NET binary. And also the Detector-Easy gave me some signs of a lot of .NET obfuscators. But there are like tools that automatically deobfuscate code, but looks like D4.dot, that is one of them, couldn't do anything with that one. So maybe this is just to distract, and I checked that indeed it was that. But yeah, .NET code can be decompiled with software like dnspy. So I load the binary there, and I quickly discovered that the code was really obfuscated, like heavily obfuscated. There are like many pieces of obfuscator there, but it was some custom obfuscator. There was not any like known software used there. But to make it more complicated, they also run the code in multiple threads. So each core section of the code is running in an independent thread. So you need to debug each one. And also there was like a lot of junk code inserted that is doing like garbage and nothing. So there are like multiple paces needed to figure out where the core functionality resides. But yeah, with passions, I figure out where are, and I also passed for one section where I discovered that also the panel URL was the C2, the panel they use to exfiltrate the data is in plain text. So even they took a lot of effort to obfuscate their code. They just put the C2 URL in plain text. So having that info and, as I said, like spending some time debugging the sample and reverse engineering it, I discovered what was the main purpose of this sample, which is primarily it gathers all the system info it can, like invoking common .NET functions, and it gathers like computer name, username, the hardware ID. It checks also for running processes, the installed programs you have, and it tries to gather all that information like quickly in a single run of 20 or 30 seconds. But that's not all. It's also search for a lot of valuable information in the computer, like like cryptocurrency wallets, searching for .wallet files in the system, all that ones, Namecoin, Monero, Bytecoin, all of them. It's also search for saved credentials in the browsers installed in the system, like Firefox, Chrome, all of that, which is stored in SQLite database, most likely. And it also searches for VPN configurations files from clients like NordVPN or ProtonVPN, also messaging clients, FTP credentials. It also searches for Telegram conversations and data you have about Telegram, if it's the client installed in the computer. And also search for exfiltrate some specific files like documents, images that is stored in the desktop, or documents or downloads. Finally, it's also take a screenshot of the computer. So yeah, I try to gather as much as valuable information as possible in the time. So after all of these pieces of code are run, it tried to pack everything in a compressed file, a zip file, with a certain structure. And depending of the version of the malware, the mechanism to send it to the panel differs a little bit. So once I have more or less the whole reversing process made, but it's also like a parallel task, I try to research a little bit more about this family of malware that I thought it could be interesting to search. And I found that Microsoft Security Intelligence was talking about a .NET info stealer in the wild that was advertised in underground forums since January. And yeah, it was describing all the capabilities that I just showed you. And it also shared a couple of samples. This is the tweet they made. And yeah, searching a little bit more, I found that, as they said it was advertised in forums, I tried to find where it was. So I found all these forum threads where the malware was actually advertised, and they was indeed saying that it was a .NET stealer that was built with that C++ loader implementing the CLR hosting technique that I show you. And yeah, it was very active from January to May, when suddenly the developer decided to stop running this malware. But yeah, the price for it was yeah, depending on the month, it increased a little bit. They made some offers. And they commented in this thread that there was like 200 clients who bought the license for this malware. So there are two threat actors that I identified in these forums. One is called Overdot. This is the username he used. And it was in charge of selling and promotion of this malware. And it has like a couple of contact ways, like Telegram or Jabber, with these usernames. And there's also another actor called Lord Odin that he said in this post that he was the malware developer, actually. So you can contact him on this Telegram, and this is his Twitter account. And they also created a Telegram bot where if you buy a license for this malware, you have access to this Telegram bot where you can actually get build new binaries for yeah, like clean versions. And also you can grab the C2, the panel, PHP code and the SQL database and all the stuff. But the buyer needs to install it on his own server, but the seller provides a couple of manuals to install and update the malware. So once I have all that information, what I was searching for, it was to catch them all, you know? So I tried to, yeah. As I have the binary that I search in the memory and the other ones shared by Microsoft, I use a tool that I created called strings intersection, and that just search for common strings in Unicode and ASCII in the binary, and I try to get some of them to create a solid Java rule to search for these binaries. So I create this one just with saying that is a p header, file size, and that contains all of these strings that I think could be interesting to just identify this malware. And I also decided to do the same with the C++ packer, because it's like the entry point. So to search for more binaries, I keep searching for Balder Stealer threads, and I found a couple of more binaries, and I did the same. I searched for the strings it contains, and I created a Java rule. So I used the VirusTotal RetroHand service that passing a Java rule, you can search on his complete database for binaries, files that match with my Java rules. So
2 hours later.
Literally 2 hours later, I was able to find a lot of new binaries. And now I have all of them. Well, what I try to do is like automate the process of extracting, because remember the panel is inside the .NET stealer. So as I had also the C++ loader, I need to first extract the .NET stealer from inside the packer. So I try to automate that process to don't have to go in by one-to-one doing it. And I create this piece of code that I don't know if you see. Okay, but I can zoom it a little bit. So first of all, I'm checking if it's the proper packer, searching for the CLR create instance string in there. So if it's the packer, I found a couple of regex expressions in the X mode that can give me the address of where is it located, the cipher binary inside in the data section. So I gather the cipher offset first, and then as I know it should be an XOR algorithm, I found for the key and I just try to apply a plain text attack. So I know that the header should look like that, so I just try to find an XOR key that match this header. So once I'm able to find that key that gave me this header, this is the XOR key, and I can use it to apply to the whole buffer cipher buffer. In that case, I pass it to another function where I try to detect which version of the malware is it. Because the developer was very active during this month, and he released like up to 3 major versions of this malware, and there are some certain changes in there. So I want to be able to gather this info from all the versions. And as I checked that the malware was sending a zip file to the panel, I was also able to check that this zip file was extracted in a certain path in the panel called logs. So if I search for the logs path in there and searching also for my hardware ID, I can be able to find the content that just got sent to the panel. So luckily for us, some of the buyers of this product were not taking care of his security, and they just left the panel's code available in an open directory. So I was able to actually download the code of the panels and try an exploit idea that I had in mind. So this is the panel code for version 2 and version 3. They just include a module for GeoIP service in the version 3, but more or less the main change comes in the specific files, in the gate PHP file, and also the way they manage to log into the panel. So this is the login for the admin panel. In versions previous to 3.0, it was using a fake SHM4 login page, but they changed then to basic authentication, maybe because it was very easy to search for those panels with a showdown search. So they decided to move from a database store username and password to this one. And taking in account all these differences, I found that there are three possible cases. So for version 2.1 or less, the zip file was getting sent like in plain mode, just sending the zip file to the panel to gate PHP with a post request, sending these parameters in there. And then for version 2.2, they include a little change. So you make a post to gate PHP. It gives you a 4-byte XOR key, and it uses it to concatenate parameters with the 3 stars and the zip file. It's everything is ciphered with that XOR key, and then send the zip file cipher to the gate PHP via post like before. And then for the latest version release of this malware, for version 3.0, it was also based on that XOR key, but they changed because it sent the XOR and other data, so they changed the separator for that. And in this case, you have to make 2 post requests. One sending the parameters cipher with the XOR key, and then another different request with only the zip file cipher. So I make this code to differ between version 2 and version 3. And in this one, I only send one, and in this one, I send first the parameters and then the post with the zip file. So yeah. After that, once where I include, I grab the zip file and I put inside a PHP shell that can give me access to the actual to execute commands in the server. So one interesting thing that you can think on grabbing from there is the login credentials for the admin. So depending on the version, remember that is like database based or basic authentication. For the first one, I just made a bash command that simply prints an echo, so prints a PHP file that searches in the database for a row called, it queries select from user info, and it searches for all the logins in the database. And I call it dump PHP, and I just make a get to this PHP that I just created in the server. So this way I can gather the admin username and password. And in the other case, I just search for a file called database PHP that is stored inside the code, and they have the login and password there, but the password is in MD5 form. So I also include another library that can search if the MD file, it's called Buster, and with this tool you can search if the MD5 is like cracked already or is a known password. So I can check if we can guess the password like that. So running it in my local host, as I have the panel code, I just try to run my script. So I simply say that this is the URL that is using, and I pass the parameter E to say that try to exploit it. And it check that give me a 41 unauthorized code. That is usually what you get when you try to when you use basic authentication and you don't give the auth. So I was able to know that this is panel version 3.0, and as I say, okay, try to exploit it. So I gathered the XOR key that gave me for my public IP, and it says exploit successful because it was able to upload that web shell PHP. And I searched for the credentials in that database file, which was admin and this MD5, and running it in Buster. I just put a simple password 1234, and you enter it in the login in the index PHP, and you have access to the panel. So this is the view that the buyer of the malware will see the info they stole. So another idea that I have in mind, in case someone was thinking on exploiting live panels, it was okay, they are gathering some info from other people. Let's try to search if they have info from our clients. So as they store the passwords and credit cards info from the browsers, I decided to just run a find command with searching for passwords.log file that are not empty, or whatever cards file that are not empty. And I just try to parse the info that is in there, and then I I try in the one side for the credit cards info, make a query to bin list that tells you if which bank is the owner of a credit card. So then comparing it with the list of our clients, you can know if it's actually a credit card from, yeah, like any bank or wherever. And then also for the leaked passwords, as we store a list of all the URLs that our clients have, we can also search for certain URLs that match with a password they have leaked. So this way you can, yeah, just notice, hey, one of your credit cards has been stolen in case the user didn't notice. So this is for this part. Luckily for us, suddenly when the version 4 of this malware were expected, looks like that due to some internal rivalry between the selling and promotion of the malware and the developer decided to stop maintaining the code of this piece of malware just in the time it was rising in the cybercrime ring. So, but yeah, it was like very active threat during this month, during January to May. Yeah, that's it for today. This is my contact info.